Hello there, this is Rafin. In this video I'm gonna show you our experimental setup. In our lab we have 6 setups for experimenting various electric machines, especially for energy conversion aspect of it. So we'll see different type of electric machines that converts energy from one form to another. So if we look closely to any of the setups, say for example this one, we'll be able to understand rest because they are identical. So we'll look into the power supply first. So we have a separate section dedicated for AC power supply. If we look at this section, this is the section I'm talking about. We have a fixed power supply and we have variable power supply. If we look closely, then we'll see it can actually supply 3-phase power. It can also supply single phase having A and N connected. N is for the neutral connection, and we can also use AB to have 2-phase connection. We can also have like BC as 2-phase connection. So we can choose. We can actually we can choose from fixed connection having a single phase, 2-phase, or 3-phase. Again, we also have another set which is the bottom section. It is a variable power supply, so we can actually change the value of voltage from 0 to 240 or 140 volts AC. So in both cases the power supply can supply up to 4 watt, but for fixed AC power supply, fixed voltage AC power supply, we can go up to like 15 amps. For variable, it is for 9 amp highest. So we also have a ground port here, and if we look on the other section of this setup, we can see that we have similar fixed voltage supply for DC, which is direct current power supply, and we have here variable direct current power supply. So we can, with this setup we can supply power to an AC machine, and with that power supply we can connect DC machines. So now I'll be talking about the measuring equipments that we have. We have quite a lot of AC meters and DC meters well equipped with this setup. So we have, if you look closely, we can see that we have AC meters, AC voltmeters, AC ammeters, and we also have AC wattmeter, and the range for this machine is kilowatt range. And we also have DC meters here on top, 2 sets of voltmeters, 2 sets of ammeter. On top of that, we also have a power analyzer. This is a true RMS power analyzer. By using this power analyzer, we'll be able to measure watt, power factor, voltage, RMS voltage value, then current. So we'll be using this machine and those machines if necessary. It depends on the structure and type of experiment we're gonna run. Now we'll be talking about one of the machines. So the first machine we'll learn is a 3-phase transformer. Although this is a 3-phase transformer setup, but we can use a single phase setup, or 2-phase setup, or 3-phase setup. So these are all single phase transformer. If we can arrange it, we can use them like single or 2 or 3-phase manner. So how are we going to actually connect them? So we normally use this type of banana cables to insert in one of the power supplies and connect to with the other lead. We'll connect it like so. So this way we can connect and power, like supply power to the machine. So I will be, since it is a introductory class, we are not gonna go into the detail about the construction and other aspects of a machine, how we are going to connect them, or how we are going to measure voltage and current or power. But we are focusing on the introductory aspect of it. So again, we have that I have already talked about the transformer. Now I'm going to talk about the loads. So this is a machine that converts voltage from one form to another depending on the requirement. So we need to actually supply the voltage from this end to the transformer to the load. So this is the load that we have different other kinds of load I'm going to show you, but this is the basic load that we normally use in most of the experiments. So we have resistance load and we have reactance load. In a resistance load, we have resistive components. Each we can actually change the value using these dials. So we can change according to our experiment. We can change it. We can use them in single phase manner, two phase manner, or three phase manner. So what if we need a reactance load? Like, although this is only for AC, but we'll see. But because in DC, these inductance and capacitance actually behave differently. So normally for experiment, we normally use LC components for AC only. Anyway, so as I was telling you that with respect to the experiment, we'll decide what type of load we are going to use. Are we going to use R load, or are you going to use reactance load, or combination of both? Like we could use RLC or RL. So it all depends on the experiment. So normally in industrial level, we have RL type of load. So 90% of the loads are RL type. Now, since we have talked about a machine which is called transformer, this is also a stationary type of machine, so it doesn't move while working. So but we also have different rotating machines. So these all are different types of rotating machines. So if we start from here, we have universal motor, we have DC machine, we have synchronous machine, we have induction machine. This is another type of induction machine which is called own rotor motor. We have multifunctional machine. So this is also an induction machine, but it is a single phase induction machine. For an induction machine to run, especially a single phase induction machine is not self-starting, so it needs some sort of self-starting mechanism. So we have here that mechanism. So we have main winding, auxiliary winding, and some other mechanism that is used for it to run initially. So we have single phase AC machine, we have very traditional induction machine, that is actually 90% of the machine in the industry that are of induction type. So this is called squirrel cage induction machine. This is a three-phase machine. So if we look at the nameplate, it says alternating current machine, that means AC machine. So the voltage is 208, amp is 1.4, and the RPM, which is rotation per minute, it is 1725 RPM. So that means in a minute it rotates from one end to another 1725 times. So we have induction type machine. We also have a special type of induction machine which is called own rotor motor. We'll talk about those in future. and we have synchronous machine. This is a very special type of machine. Actually all electric machines are special, but this we call it I consider this machine as very special because it can work as a motor and it can also work as a generator. So in case of a traditional induction machine, it is very difficult to construct a induction generator, although there are many induction generators, but you need to actually use a different type of topology and different type of winding structure to actually make this induction machine a generator. Anyway, so this is a synchronous machine. So there are differences between all of these machines, so we will learn them in our theory classes, and we'll also learn them about their performances in our lectures, labs. So this is like a load, you can say a load to this type of machines. When we want to see the performance of each machines, we'll use these type of loads. And also we are gonna use, why we are gonna use like this type of load, like if I mentioned it correctly in my previous section, that I have mentioned that for a transformer the loads are resistive or inductive or capacitive. Why is that? Because the input of a transformer is electric power or energy, and the output is also electric. But in case of a motor, if we talk about motor, rotating machines are two types. One is a motor, another is a generator. So in case of, if we talk about a motor takes electrical energy and provides the output will be mechanical. So if I connect with those banana cables to one of these leads and supply power, electric power to this machine, it will start rotate from here. So it will generate mechanical power. So in case of a motor, the input is electrical and the output is mechanical. But in case of a generator, so we are going to provide rotation, like for instance like this rotation will have electricity on these leads. So in synchronous machine is a type of machine that can work as a motor and a generator. I'm not saying that induction machine cannot, but the mechanism, like 90% of the generators out there in the market are of like synchronous type. So how we are going to test this in that case, like how we are going to actually provide mechanical power to this synchronous machine? All we are going to do is we are going to connect this induction machine to an AC power supply, and this machine will start to rotate, right? And we have a coupling mechanism here. So if this induction machine starts to rotate, it will actually rotate also the rotor of this generator. So in that way we're gonna get the electricity from this. Anyway, so that is one way to get the performance of a synchronous generator. We are going to use these as loads of motors to actually measure the mechanical output. And so these four types are AC machines. Now we are going to talk about DC machines. So there are quite 2, 3, like 4, 5 types of DC machines. So you will all see in the lectures. So with this setup we can actually test them all. So we will test them in later. And finally we have a universal motor. So universal motor is also a very special type of motor. It can actually take AC or DC power. So this machine, it is a DC machine. These four machines are AC machines. So these AC machines only can take AC power or give AC power. Like for instance, this synchronous generator will provide AC power as output, but they will take AC input, and DC machine will take only DC input. But universal motor can take either AC or DC. So we will learn each and every machine in this course, and we'll talk about the theoretical aspect, and we'll also talk about the practical aspect of it. So again, we also have, let's not forget, we are not going to talk about only these type of machines. We are going to talk about other aspects of energy conversion, say for example renewable energy. So we have like there are 2 or 3 types of renewable energy that can be actually tested in this lab, in this facility of ours. So we have the capability to have wind energy conversion system, we have PV, and we have battery, which is energy management system. So in our setup, we'll see, although we don't have wind propeller, but we have the profile of wind. So we'll use electronically, we'll provide this profile, wind profile, to this machine, and so this generator per se. So this generator will actually produce electricity. So we are gonna take wind as an input, and we are gonna provide electricity with the help of this generator. So this is the wind emulator machine, which is of 5 kilowatt. So this is the wind emulating machine. So this will actually create the wind profiling to and supply this to this generator. So from this output we'll get electricity, and to control this machine and output of this generator, we have an inverter system here. So this is a setup of wind emulator machine. We also have similar PV emulating machine and energy storage system. So we'll talk about everything, we'll learn about everything, and we'll in some cases we'll use experiments, like hands-on experiments. I'll show you how to actually exercise these experiments, how to measure the values, output values, like in terms of like voltage, current, power, and how we are gonna use those data to exercise or to measure the performance of these machines. And also we'll simulate. That means we'll use computer aided softwares to actually simulate the performance of different electric machines and wind energy sources, like say for example wind and solar and energy storage devices. So that's all for today. So we'll see you in next week's class. So not see you, anyway, you get my point. Thank you so much. If you have any question, you can email me, you can post it in on the Canvas platform. Thank you so much.